The most distant human-made object is NASA's Voyager 1 spacecraft, which has managed to venture into interstellar space. Imagine launching a spacecraft 45 years ago and still exploring regions it was never expected to reach, well past its intended lifespan. This is the extraordinary reality of NASA's mission, which is reshaping the way we view space exploration. However, there's an even more astonishing aspect. This daring spacecraft is not only millions of miles away from its origin, but it also continues to transmit data back to Earth using technology older than a cassette player. That's not all. The spacecraft, launched in 1977, made a groundbreaking discovery that has stunned the scientific community and captured global attention. What exactly is this remarkable find in the farthest corners of space? And what implications does it hold for us on Earth? There was a pivotal moment in history when two of the most incredible space missions ever were launched, marking the beginning of the space exploration era. Thanks to the brilliant mind of Gary Flandreau from NASA's Jet Propulsion Laboratory, a perfect trajectory was mapped for the probe to reach distant planets such as Jupiter, Saturn, Uranus, and Neptune using only a pencil and 21st-century engineering tools in the late 1970s and early 1980s. Flandreau made a stunning revelation. The four gas giants would align in an exceptional cosmic pattern, forming a celestial necklace along with Earth. This alignment allowed spacecraft passing near each planet to gain speed. Voyager 1's incredible 45-year mission was as if being pulled by an invisible rope. Due to this gravitational boost, a journey that would have normally taken 30 years from Earth to Neptune could be completed in just 12 years. However, there was a catch. This alignment occurred only once every 176 years. Seizing this rare opportunity, NASA acted swiftly, and within just 15 days, they launched two identical spacecraft, Voyager 1 and Voyager 2, in the summer of 1977, aiming to capitalize on the cosmic alignment. Little did they know that these twin spacecraft would go on to break all space mission records. More than 45 years after their launch, Voyager 1 and Voyager 2 are still operational, sending valuable data daily from the outer reaches of our solar system. These remarkable spacecraft have become the farthest objects ever sent from Earth, having journeyed far beyond what was initially imagined. This is especially impressive considering their original mission was expected to last just 4 years. However, these interstellar pioneers have kept surprising us. At the start of their journeys, they provided extraordinary close-up images of Jupiter's and Saturn's moons, revealing worlds far more active and dynamic than scientists had predicted. Discoveries like active volcanoes and icy landscapes forever changed our understanding of these distant solar system corners. Voyager 2, in particular, was the first spacecraft to visit Uranus in 1986 and Neptune in 1989, becoming the only probe to ever travel between these two planets, surprising scientists with astonishing revelations in previously uncharted territories. Located over 14 billion kilometers from Earth, these compact probes continue to defy all expectations and expand the boundaries of human knowledge. What is this impossible discovery? The Voyager journey began with a gravity assist maneuver around Venus, a technique never before attempted by any spacecraft on its way to Mercury. This made the Voyagers true pioneers. The journey to Jupiter took them 10 times the distance between Mercury and Earth, requiring them to pass through the dangerous asteroid belt, a feat previously achieved by Pioneer 10 and 11 probes. But the challenges didn't end there. With just 69 kilobytes of memory, far less than that of a modern smartphone, the onboard computers had to use their own intelligence to manage the complexities of the mission. Data collected by the spacecraft's instruments was stored on magnetic tape recorders before being transmitted back to Earth through a transmitter that only used 23 watts of power, about the same as a light bulb. These probes were equipped with 12-meter diameter satellite dishes to maintain communication, using light-speed radio waves to send and receive messages. However, the increasing distance from Earth, advancing by 3 to 4 light seconds each day, created significant challenges. For instance, it took more than 18 hours for signals from Voyager 2 to reach Earth, and growing background noise from radios, televisions, and cell phones made it more difficult to detect the spacecraft's faint signals. Despite these hurdles, the Voyager probes continue to defy expectations, surprising astronomers with unexpected discoveries in the vast interstellar void. Their mission has redefined our understanding of the cosmos, reshaping our perception of the unknown beyond our solar system. Beyond our solar system lies the mysterious Oort cloud, a vast region containing comet-like objects bound together by the sun's gravity, extending to the nearest star. Although the Voyagers continue their slow movement toward this distant realm, their entry into interstellar space began when they crossed the heliopause, the boundary between our solar system and interstellar space. Initially estimated to be about 50 astronomical units from Earth, the mission continued to receive funding as the spacecraft approached this milestone. However, crossing this boundary didn't immediately reveal the expected changes in the environment, leaving scientists puzzled. The entry into interstellar space was anticipated to trigger an abrupt increase in cosmic rays, high-energy particles traveling at nearly the speed of light, ejected by supernovae and other cosmic phenomena. However, most high-energy particles are deflected by the magnetic shield of the heliosphere, which protects our solar system from external threats. The Voyager mission team closely monitored any shift in the magnetic field as the spacecraft entered the interstellar medium, a region composed of ionized gases influenced by nearby stars. The interstellar magnetic field was expected to differ from the heliospheric changes. On August 25, 2012, Voyager 1 finally crossed the heliopause and transmitted fascinating data confirming an increase in plasma density, although there was no change in the magnetic field. This was unexpected, as scientists had predicted that moving from a region dominated by solar magnetic fields to one influenced by other stars would result in noticeable changes in the magnetic field's direction. If you have thoughts, let me know in the comments. And if you like the video, don't forget to hit the like button and subscribe to the channel. Voyager 1's journey into the great unknown has significantly altered our understanding of space. Its data continues to provide insight into regions previously thought to be unreachable. Even as these spacecraft venture further into interstellar space, each new discovery adds to the growing picture of a universe that is far more complex and fascinating than we ever imagined. One of the most notable aspects of the Voyager missions is how they've been able to send back data despite the extreme distances. The spacecraft are now so far from Earth that the time it takes for their signals to travel back has increased dramatically. This means that the teams monitoring them on Earth are dealing with significant delays in communication, which only adds to the challenge of operating these probes. Yet, despite these obstacles, the Voyagers have proven remarkably resilient and continue to exceed expectations. The advances in space technology that made these missions possible were groundbreaking. The ingenuity behind the design of Voyager 1 and 2 has set the standard for many space missions that followed. The data they've returned has not only advanced scientific knowledge but also captured the public's imagination, turning them into symbols of human perseverance and curiosity. These spacecraft are much more than just machines. They represent the unyielding desire to push the boundaries of what we know and to explore the unknown. Over the years, both Voyager spacecraft have transmitted invaluable scientific data, enhancing our understanding of the outer solar system, the interstellar medium, and cosmic phenomena. They have uncovered secrets about the planets they've encountered, from the stunning volcanic activity on Jupiter's moon Io to the vast rings of Saturn. With their onboard instruments, the Voyagers have also provided data on magnetic fields, cosmic radiation, and plasma environments, offering insights into the nature of space itself. Even though their primary mission has long been over, the data they continue to send back is still vital to scientists working in various fields, from astrophysics to space weather. The importance of the Voyager missions is not just in the data they've collected, but in the spirit of exploration they embody. Launched at a time when the space race was heating up, the missions represented a bold leap into the unknown. The vision behind them was not just to gather information about nearby planets, but to push the limits of human understanding and capability. With these missions, NASA proved that even in the vastness of space, there is no limit to what we can achieve if we dare to reach out and explore. As we continue to send spacecraft farther into space, the Voyagers remain a reminder of what is possible when we aim for the stars. Their longevity and continued success are a testament to the dedication and brilliance of the scientists, engineers, and visionaries who made these missions possible. In many ways, the Voyagers have opened a door to the future of space exploration, paving the way for even more ambitious missions in the years to come. And while Voyager 1 and 2 will eventually cease transmitting their valuable data, their legacy will live on, inspiring future generations to continue exploring the stars. Conclusion and final thoughts. Let me know your thoughts on this incredible mission and the lasting impact the Voyagers have had on our understanding of space. If you enjoyed this exploration of space and the unknown, please like and subscribe for more updates. Even as Voyager 1 and Voyager 2 venture deeper into the cosmos, far beyond the realms of the planets we know, they continue to teach us valuable lessons about the universe. The data they send back challenges our existing theories and opens new avenues of scientific exploration. Their discoveries have expanded our understanding of the solar system and interstellar space, providing insights into the environment outside the sun's reach. As they travel farther from the solar system, they are essentially becoming our first ambassadors to the interstellar frontier, representing humanity's thirst for knowledge and the desire to push the boundaries of exploration. The conditions in interstellar space are vastly different from what we experience in our solar system. The sun's influence gradually fades as the Voyagers travel farther away, and the environment is shaped by the magnetic fields and particles from distant stars. Studying this part of space is crucial for understanding how the universe functions beyond the protective barrier of the heliosphere. This region is largely unexplored, and the information gathered by Voyager 1 and Voyager 2 will continue to be a key piece in the puzzle of space exploration for years to come. One of the most significant findings from the Voyager probes is their ability to capture a new perspective on cosmic rays, high-energy particles that travel through space. These rays, which are released by supernovae and other powerful cosmic events, have been largely deflected by the protective magnetic field of the solar system. However, as the Voyagers have ventured into interstellar space, they have been able to measure these particles directly, offering us a unique view of these cosmic phenomena. Their data has helped scientists learn more about the composition and behavior of the interstellar medium, deepening our understanding of the broader universe. What is truly remarkable is that despite the spacecraft's age and the vast distances they've traveled, their technology remains functional. Their mission was expected to end long ago, but their lasting power is a testament to the durability of the design and the foresight of the engineers who crafted them. They continue to provide data with incredible accuracy, even though their power sources and communication systems are not as advanced as the ones we use today. The fact that these spacecraft are still operational is an extraordinary feat of engineering, making them some of the most enduring objects ever created by humanity. As the Voyagers continue their journey, they are gradually reaching the edge of the known universe. Eventually, they will drift far beyond the range where their instruments can transmit data back to Earth. But the information they've already gathered will continue to shape our understanding of space for generations. The success of the Voyager missions has led to numerous other space explorations, including the study of asteroids, comets, and the search for life on other planets. Their legacy will remain a key part of the history of space exploration, inspiring future missions that will expand on the foundation the Voyagers have laid. In the coming decades, we may have the technology to send more advanced spacecraft even farther into space, but the Voyagers will always hold a special place as humanity's first true interstellar explorers. Their journey reminds us that the quest for knowledge is never-ending, and that even the smallest probes, like Voyager, can have an enormous impact on how we understand the universe.